Hi there, Physics 152. This is the experiment video for Practical 5. The first activity, Activity 2, is called Dielectric Permittivity of the Air. So the purpose of the activity is to measure dielectric permittivity of air using this, it's called the ES 9079 basic variable capacitor. So it's two metal plates, and you're able to adjust the separation between them. They're parallel, they have a certain area. So I think your first step is just to measure what the diameter of the area. You have to find the area of the plate, so you can use a ruler, measure out what the diameter is, to find the radius. Pi r squared is going to be that area. And then you want to use a capacitance meter to measure the capacitance of the parallel plates. So I can do that. This is called a capacitance meter. It has all these various different settings on it. The settings, what they label is the maximum capacitance that you can measure using this. So it goes from 200 picofarads being the most sensitive, and the least sensitive setting way up here is 20 millifarads. So this thing it's not possible to measure more than 20 millifarads with that. I guess you can just clip on these little alligator clips to the two different plates, red to one and black to the other. That's not very many. What is the... I'm just gradually going down to nanofarads. Now I'm starting to read it. 2000 picofarads. There we go. Once you get into picofarads, it looks like you can actually start to get a bit of a reading on this thing. And hopefully when you decrease the distance between them, you can increase the capacitance. Okay. We also have these calipers. So the calipers, when you put them together and press the 0 button, they measure the distance between these two little arms of it. So if you slide this out now, you can measure the separation between the plates. So I see there, looks like 22.2 millimeters between the plates, and 84 picofarads. So you can make a plot. Okay, so your next activity is called Activity 3, is dielectric permittivity of textbook paper. So for this, you take a book. For this, I'm actually just using your actual textbook, and you should have a copy of that on your table. And you're looking at these little pages, and I guess you could try to measure the thickness of one sheet of paper, but I think it says, what does it say, 0.07 millimeters. It's pretty hard to measure. So what you could do is actually measure a bunch of pages and then divide by the number. And don't forget, the way the page numbers are numbered in this book is, they're numbered on either side, so you have to divide by 2 there. So if I go, from like page 1 maybe to page 1000 or something, and then take that measurement and then divide by 500, I should get the thickness of one piece of paper. So you need that. And then we have these metal plates, which you can hook the alligator, again, of your capacitance meter to each metal plate. Now that I have these two metal plates, I can put them, slip them into the textbook, separated by a certain number of pages. So I can put this on page 123, and then carefully place, maybe on page 23, place this parallel without shorting it out, and then kind of close it, and measure with the capacitance meter what the capacitance is of these two plates. And I can, choose different pages, and again, make a plot of the separation distance versus the capacitance, except now I should be able to determine kappa, what the kappa dielectric constant is for textbook paper. Okay, I want to show you the stuff for Activity 6. So first of all, you've got two light bulbs, and one's called 6 volts, 3 watts. So that sort of indicates how much resistance is in that light bulb. The other light bulb is called 6 volts, 1 watt. So it shows you, I guess, how much power the bulb is supposed to output when that amount of voltage is applied across it. The other thing you have is a couple of capacitors. These are these little purple things. And what are they? There's one of them, it's a little hard to see the label. This one says 1.0 F, so 1 farad. And the other one says 0.47 F, so 0.47 farads. You also have your 6 volt battery that we used last class. And we also have a multimeter. We have a switch. We have a whole big pile of these banana cables, which we might need. And we have 2 of these little alligator clips, so be careful not to clip them to your finger. Ow! Like that. First step is to take the 1 watt light bulb and connect it up into a simple circuit using the switch also. Red to red. Let's start with the switch. Put through the light bulb, ground it out through the 0.47 farad capacitor and back to the battery. So when I close the switch, the light bulb goes on. But what's interesting is that if you wait long enough, the light gets fainter and fainter. I don't know if you can kind of see that. This takes a little bit of patience, but what is happening is that you are gradually charging up the capacitor. It takes some time. So that's what I mean by describe what happens when you close a switch, is maybe even look at your watch and try to figure out how long it takes for this whole thing to go down. And if you want to start the whole experiment over again, you have to be careful to discharge your capacitor again, maybe through the wire. Try to ground it out so that all that charge on the capacitor goes away. And then when you hook it up again, turn on the switch, the first thing that should come on is the bulb should be bright at first. So once this has been closed long enough so that the light bulb doesn't go on, the next step is to take the battery actually out of the circuit and mess around with this and see if you can make the light bulb go on again. And then the next step is to take your voltmeter and plug red into V, plug the black into COM, turn it on to DC volts, maybe put it at 40 or something, and then measure the voltage that's across the capacitor to see if your capacitor is actually charged up. So that's a basic introduction to all of the apparatus that you're going to need for these week 5 practicals. Good luck as the lead experimentalist, and the last thing I'm going to do in this video is quickly tidy things up. So have a great week, and I guess I won't see you till after reading week, a couple of weeks after reading week, when we resume for practical 6. I'll see you then. Bye.